Yes, we are on live now. And who's there from your team, Abhishek? Who is ready?
Uma is joining.
Okay.
Just easy.
Hello.
Yeah, hi. We have few minutes to start.
I'm a bit tensed, Abhishek, because I'm not prepared. I don't know what I will do with today.
No, I know. Even though Anuradha is also here.
Okay, right.
Yeah.
Bhupend and Anuradha. So you are going to present or you will be as a backup for Uma for assignment number 5. Sorry, 4.
But I'm
I
going
didn't
to
get
present.
You are going to present. Okay. Okay. No problem. So, okay, Uma, then you just stay here and see. Okay. As you are not already prepared,
Okay.
just see. Okay. Yeah.
All
Thank you
right.
so much.
Yeah, thank you.
Meantime, we can ask our students to watch live this demo. Let's share that link.
Hi, Rag.
Yeah, good evening, everyone.
Good
Good
evening.
Good evening. Completed the assignment?
Yes, but I've not finished my documentation. What I did, but I've deployed all the whole apps. So this will be a good learning for me because basically what I've done was syncing because I just mumbled my way to finish it. But now when I listen now, I now understand the reason behind the things I do and all that. So that's the game changer for me.
Okay, no problem. Take your time. Okay, guys, so can we start?
Yes, we can start.
Okay.
Team leads are not there. Okay. Okay, so good evening, everyone. My name is Bhupendra Bhati. I am one of the co-mentor in DMI. I am going to present the assignment deploy EpicBook using Terraform. And please allow me to share my screen and that screen share. Okay, is it visible?
Yes, visible. We can see your VS Code.
Okay, fine. So this is the code, the entire code. Okay. So what we are going to do, we are going to deploy the EpicBook application using the Terraform. So here this is the structure of the Terraform. So let me show you here. What I have, that main file we are having, output, I will explain everything. The providers we are having, Terraform tstate file is there, Terraform tf-vars, user data and variable. So when we do Terraform init, that .terraform folder .log.scl file and that is this backup file. So it is creating the backup file. It is creating when we are running the same code after 1 or 2 or 3 times. So and when we initialize, these two things are going to create. So the first file I created, which is the provider. So we can see that there is a provider which is AWS, and the reason is that what AWS underscore reason means this where this thing will come from the variables. And there are three things when we write the Terraform code, there are three things we assign in the code palette. The first is Terraform, which is this one. The second one is provider, and third one is resources. So here the provider is AWS, and this is the required version for the Terraform, and this is for AWS. The AWS version is there, and this is HTTP. Why I will explain you later. When the main.tf, some part will come, then I will explain why I use HTTP here. So after that, I used variable.tf. In this, I defined everything, like in which region I want to create the infrastructure, that is AP South 1 Mumbai. This is the CIDR for my VPC. This is the public subnet CIDR, that is 10.0.1.0, and this is for the private subnet 2 and 3/24. And this is the instance type for the EC2 instance. The key pair is there, and username, password, and the database we are going to create. The database name will be bookstore. Why I choose bookstore? Because the configuration file having the database name bookstore. If I will give any other name, then I have to change the entire file set, like the whatever file we are using for setting. You can mute. Okay, so was saying, like, we can change the database name accordingly, but we need to change the configuration file, whatever we are doing. I will show you the files where the bug story is already there. The another thing is main.tf file. Now, when we are creating the infrastructure, the very first thing is VPC. So here we are creating the VPC. So again, this is the resource type and this is the resource name. And this is the resource. We are intending that this is the resource we are creating. Then resource type is VPC and we are giving the name that main. And the for CIDR block, this is, we are calling var.vpc CIDR, which is here. You can see that VPC CIDR is here. It will take this value. And the name is EpicBook VPC. So in the VPC, then we are going to create the subnet. I think you are aware with all these things. Then we will create the VPC, then subnet. So this is the public subnet. Public subnet, again, it is the part of VPC. So we are mentioning the VPC ID. The CIDR block, again, we are giving variables. The public subnet, see, this is it from 9 to 11. This is the public subnet CIDR. So it will get the value from here. That map of public IP in launch means it will get the public IP from here. And again, I am creating the private subnets. Then availability zone, AP South 1 is there, AP South 1B is there. So now the thing we need to understand is when we are going to create the RDS database, if we will give only the one private subnet, it won't work. It will ask you to create the another private subnet, or because for this availability zone, for the single availability zone, it won't work. So it will ask you to create the another one. So here we are creating the two private subnets. Okay. And this is the internet gateway. Of course, we need the internet gateway for the communication. This is the VPC ID again we are giving, and this tag is EpicBook IGW. And then we need route tables. We need to create the route tables. Same thing. So this is the type for the route table. This is the name for the route table. This we are using to reference from the another. If we want to call any resource, then we will use this type and this name. Like this, AWS Internet Gateway.igw.id. So we created this internet gateway. So the resources, the type and the name, we are using this to call the resource. So this is the route from anywhere we can receive the calls. Now this is the subnet association. In the subnet, we need to associate the public IPs. Public route we need to associate. So we in the route table association, we are giving the public subnet so that it can access the things. Now, see, this is the thing. Data, HTTP, my IP, and this is the URL. So what it will do, when we are doing SSH, we are using, if I am using my personal PC, so I am using my IP in that AWS inbound rule. So here what I am doing is, I'm not hard coding the IP address. I'm using this data, HTTP and my IP. So for this HTTP, we need provider. So that's why the HTTP is here and this version is here. Okay, and this is the URL like HTTP check IP amazon.com is. Okay, and again, where I'm using this here. So here I'm creating the EC2 security group. So this is the security group name. Again, I'm referencing the VPC ID. Now I am using port 22. So for this port 22, this is the protocol and I'm using the CIDR block and it will get the IP from here. So when it will fetch this, the IP will get by this thing and the value will be assigned here. And this is port 80 from anywhere, port 443 HTTPS from anywhere, and this is port 8080 from anywhere. Okay, so whatever we are giving input, everything will come out. So this is egress for that. Now this is this security group for RDS. So whatever database we are going to create, this is the security group for RDS, and the port we need 3306 open for that. So we are doing this, and this is the security group for that. It is it will call this security group from there. It will get the IP and it will be accessible. And this is the resource EC2. Now this is the AMI. I am using this AMI. I got this AMI from AWS itself. AWS console. If you go there, and we will create on in launch instance, and we can see that AMI. So copy that AMI from there. Instance type again. I am using the var variable file. So that is T3 medium. So it will come here. The subnet ID, it will get a subnet ID like public. Key pair name is there, var.key name. It will take it here. Terraform.tfrs. Key name is here. And the security group, again, it will call and it will get the security group. Now, this is the user data. Why I am using the user data? So what my motive is, I will run the Terraform file. Terraform, as I will run Terraform apply, I will get the IP address. If there will some error, I will diagnose them and my EpicBook will be live. So this is the main thing. So let me explain the main part first, then we will go for user script. Okay, this one. So this is the DB host. Whatever DB host I will get from the Terraform apply, it will capture that DB user, DB password, and DB name. It will capture and it will give to us. It will give to the user data file. Now RDS subnet group. So this is the RDS subnet. This is the private one. And here we are referencing the two private subnet which we have used before. And this is the tag for that name. Tag means the name, whatever name we are going to give. And this is the RDS instance. This is the storage. Engine is MySQL. This is the instance size. And again, the name, username, and password it will fetch. Publicly accessible means in the output, we can't see that password and all. Okay, then security group ID is there, subnet is there. We are fetching and everything. So this is our main file. Now user data file. Focus on this. This is shebang. The line number 1. This is a shebang. That means nothing but it tells like it is the user data script. Now we are using this. Whatever manual step we are doing when we are deploying the EpicBook, only I mentioned here. So first we are doing, as we are doing SSH, then we are doing sudo apt update -y, then upgrade -y. Then we are installing the things like Node.js, npm, ngn, nginx, MySQL client, and Git. Git I am using here because suppose we are launching the EC2 instance, and if Git will not there, then it will give error because we will not able to clone this thing. So that's why I'm using Git here. Now we are going to clone the repo. So where we need to clone the repo? In home Ubuntu means the home directory of Ubuntu. And this thing, if the EpicBook folder is not there, then means if it's present there, so it won't give any error and it will clone this. So what is this? Git clone, then the repo. This is the repo, EpicBook repo. Okay. So then we will enter in that EpicBook. Now what we are doing in that? We are making some changes. I will tell you. So it will install the npm, and now what it is doing, it will go to the config.json file, and it will if we are doing this thing manually. So what we are doing, we are going to the config and config.json file. Then we are updating username, password, database, host name. So everything I mentioned here. When the Terraform apply will be successful, everything, every value will come here. I will show you. And then after this is the important thing, because we are doing the things database. When the database will spin up, it will take time. So maybe when we will use the IP address, it will give error, and after some time it will show something, maybe nginx or something. And if something inside the EC2 instance it is not working, we will diagnose and it will go. And this thing, this is the seeding. And what I told you that here in the variable, we are using bookstore. So why we are using bookstore? Because these files, when we will edit this file, so the database name is there is bookstore. That's why we are using bookstore. I will show you these files. Then again, we are installing the PM2, and then we are starting the PM2 server. If you will configure like this, then only it will work. Otherwise, the PM2 won't start. So I'm setting the path for all. If you were there in when Pratyush was presenting the PM2 part, he was doing the same thing. So I did the same thing here. Now this is the Nginx configuration file where this etc Nginx site available default. We are updating this code. So the same code is there. And the Nginx -t means we are checking the configuration file. If it is all good, then it will restart the Nginx and we can see our EpicBook, deployed EpicBook, and we can run that. So this is the entire code. This is the output, like it will show me the IP address and the RDS endpoint. I already told you about the providers. TF, when we are working on it, Terraform, so it is creating the state file. So it is here. This is the backup one. TF var file, whatever credential or something we are having, we are giving it here. And this is variable type. Okay, so now I will run the Terraform code. So let me open Git bash here.
And before to run Terraform commands, just let us know from where you write this provider code. I mean,
Which
do
one?
we need to remember provider code?
This one?
Yes. Do we need to remember this, or from anywhere we
No,
can
no,
take
no,
it?
no, no. It is available on Terraform registry.
Yes. So yes, please let us know from where we can get this kind of code.
Okay.
Let's see carefully here. There is a Terraform registry from where you can take any code. Any code means if you are going to create a resource, for example, virtual machine or anything, you can take code from there. Okay. For example, if you need to create a resource on Azure, so you need Azure provider. If you need to create resource on Google, then you need to take a provider from for Google. And same way you will get provider code from for AWS also. Okay. It depends upon your cloud on which you are going to create your resources. Provider is very important here.
Yeah, provider code we are having. Or just one second. Let me.
You can search
See,
AWS.
this is the
Yeah.
provider code.
AWS provider, just you can type Terraform AWS provider.
No,
Yes,
this
AWS
is for
provider.
HTTP. This is for like I'm doing this. This is the version. Like I want to the live web means it is going to check this thing. So my IP it is going to check. For that I'm using IP. So here it is. It is available there in.
Just
See,
go
this is
above,
the like.
just scroll up, Bhupen, scroll up a little bit.
I have shared one link. See, that will help you.
Scroll.
It gives
Yeah,
a list
scroll
of
up.
providers
Yeah.
in the chat.
Yes, you can directly search on Google also, like Terraform Azure provider. Okay, then it will directly show the same page.
Yeah, so this is where
Exactly.
all of this stuff.
Yeah,
Yeah.
just click on AWS and use provider. Just go right side above right side. Scroll up little bit. Scroll up right side. Use provider. Right side you
Use
can see.
provider. That button which is there.
Yeah. Yes. Here you can see the code. This is the provider of AWS. Okay. So from here you can copy this code. Just copy and paste in
for
your
HTTP.
provider. Yeah, for Azure also you can get it.
I think
Not HTTP. Not HTTP. You will get
No,
Azure
no, no, no.
provider.
I'm showing that.
Okay.
From
Okay.
where you
This
got
this HTTP I'm also using.
Okay.
This one.
Okay, got it.
This part. This part. So
Right.
where is the browser? Yeah. So this is like this is the part I'm using for HTTP. So everything is available here in registry.
This is really
Yes.
good. Otherwise, we always have hard code the IP address, right? So this is very good.
Yeah.
That whatever your IP at that point is, it will pick it up and then you can work on it. Very good.
So everything is here.
Basically, purpose is if you want to create anything, So it depends upon cloud. First of all, depends upon cloud. For example, AWS, Azure, or GCP, right? So based upon that, you have to take a provider from there. Okay. After that, we can take our code. For example, we are going to create a virtual machine or subnet, VNet, resource group, whatever we are going to create, we can take code from Terraform registry directly. Okay. Okay, Bhupender, go ahead.
So the main thing is I write the entire code. Some things like this data and all, like for these HTTP and all, I got from internet. Otherwise, I write everything because there is some flow. We need a
Actually,
VPC,
actually,
subnet.
I am saying actually we don't need to remember these code. That's the purpose. Okay.
Yeah, we don't remember. We don't
Yeah.
need to remember. Everything is available. But the
Yes.
main thing
Yes.
is the flow you have to remember, like what you
Exactly.
need. Actually, that is the
Exactly.
main thing you need to remember, because whenever you are creating any file like output, what you want in the provider, what you
Hmm.
want, like Terraform TFRs, if it is necessary, then what you want, and in the variable, what you want to give in variable. So everything you need to remember this thing, but not the code actually.
Exactly. Exactly. You are right. Yes. Well done.
And also you need to know how everything
So
connects, like VPC, then subnet and your IGW, all that, how you connect them together so that, you can use it later on.
Yes.
yeah, so this is the thing. We are having our code ready. Terraform init. Oh, okay. Before this, if we are having the PAM file, then we need to chmod first. So I'm already done with it, but I will tell you. See, this is the code like chmod. Then your PAM file, where it is, chmod 400. Sorry, my bad. Chmod 400. Then your PAM file. So this is for the permission. It is changing the permission. Then you can access this. So
Bhupendra,
let
can you
me
please
press the
zoom it
enter.
out so
Sure,
that the
sure.
code can, yeah, right. Yeah. Thank
Visible
you.
now?
Yes.
Yeah. So I just run this. I just changed the mode for my PAM file. That is chmod 400. Then this is the address for my PAM file. So I'm changing the permission for this so that we can access in our project. Now Terraform init. It is initializing the backend. So what is this? Let me show you in the folder. When it is initializing, it is creating this Terraform folder where it is initializing the AWS and means plugins. It is downloading the plugins and all. See, providers, it is downloading the plugins for AWS and HTTP, whatever we are giving. So that init do this thing, then it is logging means whatever state of currently is, it is logging that state. Terraform log HCL. HCL means nothing but HashiCorp language. HashiCorp and C, I am forgetting the C. So HashiCorp and some language. So this is okay. So you can see. Okay, fine. So we can see that Terraform init is successful. Let me clear the screen. Terraform plan. Now Terraform plan, what it will do, whatever resources we provide here, it will go for the planning. It will make blueprint. Like what Terraform will say, like we need to create a VPC, we need to create a subnet, 2 subnets or 3 subnets, like public subnet and a 2 private subnet. So whatever we have mentioned in this main.tf file, it is going to create. See, plan is successful. 12 to add, 0 to change, 0 to destroy. Okay, again I'm going to clean this. Oh, clear, CLEAR. Now Terraform apply --auto -EWS. So now we are applying the things, whatever 12 resources it shows us, now it will create that resources in my AWS account. And if you don't know, like you are directly working on this thing, so you need to configure the AWS account first, then only this thing will work. So you have to configure the AWS you have to done AWS configure if you are doing first time. But all of you, I think you all are experts and you are doing so many projects, so I think AWS is already configured. So this is creating, see, DB instance RDS. Now it is creating the RDS instance. It will take time. It will take time now. I think 4 to 5 minutes it will take. Like
You can show your AWS console, right? What and all it is create now.
okay, console. See, this is my जाती है भाई इसलिए समझाया yeah, so it is like it is happening. Instance.
I think VPC subnet and all, I think it would have created already. So you can.
Yeah, but I can open one tab at a time.
Okay.
See,
Okay. Some issue. Okay, fine.
yeah, not some issue that I told you, na, that the RAM got crashes, so it is working on lower RAM right now. I already ordered the new RAM. It will take time.
Then you can close this. We'll wait for, because the RDS will take some time to,
Yes, it will take time.
yeah.
Maybe 5 years, 10 minutes it will take to create resources. There are 12 resources, right?
Right.
No, only this RDS is taking time. Rest are
Yeah.
not the issue.
Yeah.
It is
Yeah,
only
do
taking
stage,
time.
yeah, do stage please.
Yeah, using Terraform, we can automate the things. And suppose if we are doing, we run this thing, and suppose if we are going to the console and we are making any changes, then we need to run Terraform refresh. Then it will refresh the state file, this file, the Terraform state file. See, it is saying unable to open because it is logged right now. So in this TF state file, it is saving the changes. But if you suppose if you run the Terraform command and you are changing something in your console, then you need to run that Terraform refresh. So what it will do, it will refresh whatever changes that you have made in the entire infrastructure using AWS console. It will accept that thing and it will save that thing in this Terraform TF state file. Otherwise, what will happen if you will going to create, if you will going to destroy the resources, it will give you an error. What error it will give you? It will says that something happen out of Terraform. Like in the Terraform, using Terraform, whatever you created the resources, but something happen outside. So that kind of some error it will give you. So never change anything using the console if you are using Terraform. And if you have made any changes, then you have to do Terraform refresh.
And I also
will-
like You use that user data to create everything, not only, updating or installing node and all that. I saw that you, set up the configuration files, everything you put it in user data, which is very good.
Yeah, because we are
Everything is made-
automating the thing. So
right.
see, maybe it will give error in this part. In which part? See, this part. This part. Only this part give the error. Otherwise, everything is working fine. Because PM2 is not starting automatically. So that's why I found this thing using GPT, and it says that okay, you can do like this. Why we are doing this? Okay, I think something happened. See, the apply is complete. Now this is the IP address. Control. Oh my God. Okay, I copied this. See, maybe it will give error because RDS is spinning up, so it will give error first time. Because things take time to start and all. See, this is giving error.
So you are saying it will take some time, right?
Yeah, I think
Yeah,
so.
it will take some time.
Okay.
See, it is automatically reloading. I am not doing anything. Meanwhile, we can SSH. SSH -RA. Sixties. Okay, I am in this IP here. Okay, fine. SSH -9. Control Shift, Control V, Enter. Yes. See, we are in the Ubuntu. Now we can check, like, see on the ls, the EpicBook is there. As we clone the repo, so cd, the EpicBook, ls, everything is here. Okay, now we can, oh sorry, see, the welcome to Nginx feature is there. Okay. Okay, fine. We got stuck here. Now we need to check. Now I will show you each and everything. Like we are going to config file. So we are doing cd config ls, then sudo vi config.json. See, everything is here. The username is here, password is here, database is here, and the what we can say that endpoint, RDS endpoint is here. So this file is good. Escape : q disclaimer. Okay. And yeah, we need to run. Okay, another file is here.
Not install.
You have to come one directory up, right? You have to come out of this directory.
Sorry.
CD dot dot. You have to come to the
Yeah.
parent
EpicBook.
directory.
Correct.
No.
Not server.js.
Yes.
Oh, it is giving some error.
I think it's already running, I guess. Just scroll down. I think already no server is running. Just check. Port address is already in use. It's already in use. So
See, the EpicBook is here because
and
that
then Excellent.
It takes time. It takes time. That's it. See, I did nothing. I did nothing. Okay, so I just check for this configuration file. I told you everything is good. And then I started this node server.js because in the backend, I already gave this code here. See,
Right.
this PM to start server.js. So it takes time. I don't know why, but it is taking time. So everything is running in the backend. So that's why it was giving error. See, it is working. Now let me add the books in the cart. I'm clicking here. See, there is 1. It is 2. It is 3. Maybe 1 more. Yes, my favorite. So we are going here. There are 4 things. Check out, and your order is placed. We are good to go.
Excellent.
So this is the way you can do everything using Terraform. There is no need to go inside the VM, and there is no need to check like some working here, anything working is or not. This is the only way you can do thing. This is the user data. I fixed everything. This is a very important thing. And see, let me show you this thing also. What this thing is having. Why I am having the database name is bookstore. So let me show you. Can I see LEAR? I'm sorry, but this panel I can't see the downside window. So okay. So MySQL MySQL -h, then the endpoint. From where I can get the endpoint.
You have it in your config file. Your config
Oh
file, you
yeah,
have it. Yeah,
correct.
just check
Thank you.
that.
Okay, CD config.
Just do a cat on it. Yeah.
Sorry, CD config. Oh my bad.
Yeah,
CD
that's it.
config.
Just do a cat on that.
Sudo.
Just do cat
Yeah,
and then
can.
yeah, just do
Yeah,
a cat. Yeah, that's it. It's copying the codes, huh?
Yeah. Wait. This is the Terraform. Okay. So, okay, I need to write the code also. So let me write SQL -h -u admin -p. And let me show you only one file. Okay. Or I will show you all 3 files. User data. I can copy this. Control C.
Will it not give an error because your database already has those tables and schema, right?
Maybe it won't give any error. Let's see. Oh, sorry, I'm doing wrong. Thank you. I'm doing wrong. Sudo.
It's in DB directory.
Yeah. Go, just wait. So I
You're in
have to
DB
go.
directory. Yeah.
Yeah, this one. Sudo vi. Yeah, this is the file. Okay. So what it is saying, use bookstore. here it is saying use bookstore, here it is saying use bookstore. Okay. And here it is saying use bookstore. So everywhere it is saying use bookstore. So if we want to change the database name, like if we want to change it from bookstore to EpicBook, then we can create the database. But again, we have to come here and we have to change all the places from bookstore to EpicBook. So that's why we are using this database name bookstore. So all these three files, like book or that author seed and this book seed file, everyone having the first line, it is having use database bookstore. So that's why we are keeping the name bookstore only, not the EpicBook. So that's why here it is bookstore. And I think everything is clear now. Nothing is here to explain. This is for seeding. If I'm not going to use this, then this your page will be there. This page will be there. The EpicBook, this home page will be there, but this books will not be there. It will be not no books. So that's why we're having this database. You know, like we are using PMP now because it will keep the process running. So that's why we are using that PMP. So yeah, this is the way we are doing this. Any doubt, any question? Yeah, Greg, please.
Thank you once again for that lovely session. But I noticed something when you were under your user data, I think under the data section, you placed something like URL equals to check my IP.dat. So what I want to ask is this. When you put that check my IP, when your IP changes from a physical machine, does it update it immediately by itself? Is that what that code is doing?
See, Greg. Okay, so I will answer you. So I think this thing is clear. So I'm closing this thing. If you want, I will show you again, but I'm closing right now. See, now I'm answering your question. So maybe you are asking this part.
Yes,
This
yes,
part,
that
right?
part. Yes, sir. Yes, sir.
Correct. One more thing. See, great. This is my IP right now. 182.64.182.159. Okay, this is my IP address. Okay. If I will close the browser or I will shut down my PC and again I will log in, my IP will change. Okay. So, and if we are using this console, then come to the security group. Okay, this is for RDS. EC2. And I can come here and see here. This is custom. Here, if I am using this console, what I can do, I can click on my IP and it will take my IP, correct?
Yes. Yes, correct.
Yeah. But I want to automate the things using Terraform. So I can't do this thing manually. I don't want to do this thing manually. Suppose if you are working in the enterprise and someone is saying, someone don't want to show, suppose I am having my PC, it is having some important files or whatever it is, and I don't want to share my public IP to you, then how you will create that code? So this is the way. Data HTTP my IP, then this is the URL, and you have to give block. So using this, without telling you what is my IP address, you can assign your PC's public IP address in this Terraform code. And where we are using this? Here for SSH.
Understood, sir.
Understood?
Yeah, because why I was asking actually was that when I was even configuring mine, it got to a stage that I could not SSH, and it was because I'm not using I'm using my phone to browse. So if I leave my system for some time, my IP changes. So I was forced to go and update it again. So that's why I'm asking, with this your own configuration, if your IP changes, does it change automatically with it, or you have to go and still troubleshoot and do that?
Yeah, so whenever your IP is getting changed, there is no need to go again. Otherwise, need to do, see, here I commented this. Previously, my IP was this, today itself.
You're not
But now
sharing
it is changed.
Your screen is not showing.
Oh my God. Now it is visible.
Yeah.
Yeah, visible.
See, so this is the Terraform tier one. So previously I was using this thing. So I am hard coding my IP address here. Okay. So I will run, suppose tomorrow I need this code, and I go to here in the panel and I will run Terraform plan, Terraform apply, then it will give error because I am not updating my IP here. So why I want to do this regularly? So we need a proper solution, and for that, what I do, I do this thing. Data, this part from 75 to 77, and the line number 90, it is giving the IP address automatically to this Terraform. So whenever I need to SSH, so it will recognize that I need to SSH from this particular IP, and this is like validated or authenticated. So there is no need to hard code the IP address. Otherwise, I every day I have to go, I have to change the IP address, and suppose, because in the real production you can't do that thing because you need permanent solution. This is a temporary solution. We can hard code the IP and we can do the SSH, but we need permanent solution. So I use this thing.
Okay, sir. I suspected it was doing something like that. That's why I had to ask.
No. See, what is the target? We need to deploy the EpicBook using Terraform. Suppose I'm having a web app, and suppose I'm your manager, I'm telling you, okay, I am having this web app and you need to deploy everything using Terraform. You can do SSH only to diagnose. Like if error comes, like if your app crashes, and also then you have to check logs and all. So how you will do that? So this is the way my application is running automatically. I only check the config file, and some other file I was checking and it was running. So it is fully automated using Terraform. You will run this code. If I will make the RAR file and I will give it to you, it will work on your system also, because nothing is hard coded.
That's great. Full
Even
automation.
even I can do this thing also, like the database password and name and all. I can do this thing also using that. So we can do this thing also. I will make another version and I will give you the code. I will share the code with everyone.
Okay. Great.
So this is the way we can automate everything. But I'm not going to share in the Group-3. I will give it to 1, 2, 4, 5, 6.
I'm number one. But it's a community now. You can't give only a few people now.
So yeah, no, I will give everyone, including 3.
Thank you very much.
Any other question?
Bhupendra sir, you know we are friends, so you give to me too, eh?
Sure. I will give everyone, not to you. I will give to everyone.
It will give everyone. It will give everyone.
Okay, fine. So if there is no question, then now very interesting thing, the same thing in interesting way using AI. Anuradha ma'am will present using agentic AI. Thank you.
Actually, what happened, like late in the evening, Bhupendra suddenly said, looks like nobody's presenting. We have to do something, give the demo. So we thought, okay, let's do it. Some discussion happened, and then he started doing the code. Even I started. I checked my code, and I had only Azure code for this assignment. I didn't have AWS. So I thought, why don't I start with? I already have Claude with me. So why don't I give something simple commands and see if it comes up with the code, and I'll just start sharing 1 minute.
My phone,
Yeah. Can you see my screen? Yeah.
Yes.
Yes, ma'am, visible.
How do I minimize
visible.
this? So much is there. Yeah. Just a
Don't ask for the skill file or instruction file. That's it.
yeah,
This is
that
not
I'll
shareable
not give.
content. This
See,
is
the thing
this is
is,
for
you
like we are not going to give it.
yeah. Because you need to know what the code is all about before you can start using it. So just
Yes.
give me a second. I mean, this whole thing, yeah. So this is my Claude code. Okay, I created one instructions.txt, and I said I want to read this file and then create Terraform directory. I think you all can see all this, right? And then add the required files like main, variable, and other things I gave. And I wanted it for AWS so that I need to give the provider name and for Mumbai region. And also, generally what happens in Terraform, you create your, you bootstrap it. That is, when you create the configuration, you first run your log file and all which gets created. You don't want it locally. You want it to be on AWS. So you create two things, that is two resources. One is AWS S3 bucket, and then you will also create your DynamoDB table. So the log and the state gets saved here. So tomorrow, even if my machine goes down or whatever the error is, other developer who can run against a change, any change they want, they can do the change and they can run it. So the first step is to create the bucket, S3 bucket, and the DynamoDB table. So this is the script for that. I think if you all have already done the the code part. Sorry, I'm not able to minimize this. So how do I?
Just,
Yeah, got
bring
it.
this and put it on top.
Yeah. I hid it. Yeah. So if you can see my screen, this is what it does. So you're anyway saying this is the provider, HashiCorp. You'll first say the provider, HashiCorp you'll give. And then you'll say, AWS is the provider, and I'm saying AP South. And then I want to create this S3 bucket. Okay. And I give a name like you normally create a bucket. And then the resource related state file, state of the Terraform will be saved here. Versioning is enabled because in case if something changes, you need to have copies, right? So for that, versioning is enabled. So then you will some rules you'll encryption. You're saying server side encryption is required, so that encryption is there. Then you will create the access policy for that. So this you will say that ACL public is blocked. All these things you'll set up for your security of your S3 bucket. Then you'll come to your DynamoDB table. Then you'll say this is the log, and then the log ID you'll specify, and some attributes which are there. You can check when you go to that site. You'll come to know from Terraform, and the name of the log which is going to. So this is the first step that you do. And then this will output the S3 bucket and the DynamoDB table. So if I share my, so this is my S3 bucket. The Terraform TF state that you found in the local directory will be saved here. Okay, so if you go to the bucket, so it'll say this is the EpicBook directory. Within that state file is saved. The same way, there is a log which is there. So if you go to DynamoDB tables, EpicBook Terraform log. So in case Terraform is running, it will lock it. So another person, if I'm running and you're also running, there'll be a clash. So it will not work properly. So there will be a lock. So when I run, whoever runs, I think there is one, if I'm not mistaken, there is one assignment where you check even for logs, right? When you run a Terraform in another terminal, you run again another Terraform. It will say there's a lock. You cannot run the second one. So this is the lock which gets created. So now this is like global. In the sense, like I can run from my PC and you try to attempt from your, it will not allow you to run it till the lock is released. So this is one advantage of this. Okay. Then it created all these things for me. So the if you go start from provider, it created all the provider. Okay. It gave the region because I had mentioned I want all these things. Then the variable files, you need all the variable, which region. You start always with a region. You next start within the region is mapped to a VPC. Within VPC, how many subnets you want? That is how many blocks of, small chunks of network you want. That is your subnet. Then you mentioned it is public, private. Just naming is not going to help, but then naming is more for our reference. Like, okay, this looks public, so it's a public subnet, or this is a private, so this is a private subnet. Then what kind of instance type, which already he had gone through, and the key pair, and a few of these things like DB and password, all this you'll mention, the DB name. So once you have done the whole thing, the output, what do you want? I want to know maybe my VPC, what is my subnet name, instance I want to know, right? What is the AWS instance? And then the IP also I want to know associated with that. So this way the RDS endpoint is required. And then the name, a DB name, I want to know. So all these things are important. So whatever you want the user or you want to see, so that you can use it later on, you can share it with your admin or whatever. All these things you will put it in your output. Okay. And here I even created a key pair. So instead of using an existing one, this is the way you can create a key pair itself. You say the resource is going to be a private key. Okay, RSA. If you do remember, locally we created RSA earlier in when we're doing GitHub, Git. Sorry. So the same way, and the same way you're going to create AWS key pair, and this is the public key that you want, that you'll specify in this fashion, and then the local file name and path where it will be saved. For me, it is saved here. If you see, this is where it is saved, the file. But how do I pass the pair name, that is key pair name? So this is the file, Terraform-TF. So Terraform-TF, any values that you have, you can put it here. But you should not check this into your GitHub. So in your git ignore, you will add this particular file. Okay, and then I also ran everything, it went through correctly. And then in the end, this is my EpicBook. So this I ran using the code, that is Claude code. And then it went through correctly. But what I liked is Bhupendra did everything automatically. I did some of the setup, which is there, following your GitHub. In your repo, there is one place where you have to follow through, install and configuration guide. So in case you want, you can refer to this, so that once you log in, you can, install Git, clone the, repo, go into the directory, and then you can do all the changes. But now this is not locally running RDS. It is MySQL is not running locally. So you need to use RDS. Okay. So that is the difference that you have in both in what the script is showing all the documentation out here and what you're going to use. Okay. This again, you will, I think you will not, yeah, installing Node already it is done through the user data. So that you may not have to do. Then yes, this is the important part where you will say -h, the host will be your endpoint and rest of the things can remain same. Okay. And then you'll run your node server. Before running your node, you should have done install and npm install, then your node server. And then your configuration file, you need to change. Okay. So that you have to do. And then you can run your sudo install reverse proxy, you can set up Nginx, and that's it. And that's it. This is the main part, so that your reverse proxy runs correct. I hope it is clear. Any questions?
Yeah,
Yes, lovely presentation, but while you were talking, I just wanted to clarify something. If I can read between the lines, this place you just opened that has installation and configuration guide. If I copy this, I can copy this text and use that as my skills or my instruction text. If I put that on the cloud, you should be able to work with that and provision the infrastructures and create the database and deploy.
See, you need to make some changes. Like the file I created, if you will copy that file in your cloud as a skill or MD, it will work. It will 100% work without any error.
Why I was asking now is, in case I'm in the field now, and what I want to provision is different. if there is a manual installation step like this, if I copy it as my instruction text or my skills, will the cloud code generate everything for me? Because
Correct.
basically
It will
what I
generate.
normally, okay.
It will generate because it is agentic AI. It is thinking, it is planning, it is taking action, it is getting action. Your action is worthy or not. If it is not worthy, then again it is planning. So there is a loop. It is working in that. The agentic AI working in that particular loop. So this is the way, like it is thinking, then it is planning, then it is waiting for the like output of whether it will be working or not. If it is working, then it will proceed further. Otherwise, it will go and again it will plan, or it will make some changes. So if you are missing something, you have to write a cloud, like you have to write something like, if there is something missing, you can add that thing. This is the line. As a prompt, you can give it to that. So it will create that things. Like Anu ma'am asked the Cloud A to create Terraform.tf, main.tf, or whatever files are there. Okay, but user script or whatever things are there, whatever she pasted from the document, it is creating accordingly. And if it seems like something is missing, then it is adding to that script or code. So if you are missing something, then it will ask you, okay, it will say like, I suppose this thing is missing, shall I add this thing to this? So you have to approve because manual intervention will be there. So you have to approve. If you think, okay, I need this thing, so you can do that. That's why it is agentic AI.
Because when I was doing mine, while it was doing the apply, Terraform apply, I think my limit finished. So I had to switch over to Open Router. And by the time Open Router started working, it messed up my Terraform setup and everything. So by the time I now went back to Cloud, when the limit was reset back again, it finished the apply. But later, I now found out that even the database was not created. So you have to start going back to do that, changing password issues. Not until I told you to remove special characters from the password. My book review came up, but I could not register. So I kind of noticed that it guides, as you were saying.
See, the Cloud A is something else. Like if you are saying that Open Router, so it is using the AI versions, and they are like that generic AI version. They are not agentic AI version. I understand these things. What is generic AI, like ChatGPT or something we are chatting with? So that is generic. That is generic AI. Okay. So it is like whatever you are. If you will talk with ChatGPT a long time, just wait 2 minutes. Hello. Yeah. So what I was saying, sorry, I have kids at my home, so they were disturbing me, so that's why. So I was saying, like, so when you're chatting with the chat GPT and you are continuously asking on something, then there will be a point if you will ask a repeated question, so it will give you some different answer. It won't give the same answer it gave previously. Okay. So in the open router, there whatever agents they are using, they are like the generic AI. So they are not up to that level, or they are still in the learning process. But if we will talk about the Cloud A, it is very powerful. So it is stick with the, like it is having some sticky session kind of thing. So whatever you are giving it will memorize, because it is having some agent. So it will memorize, and again if we will ask, so it will tell you, okay, I gave this thing to you, and if you want to modify, then I can do that. So that's why it is very powerful, and it is charging. And the open router, they are not charging, or they are giving you the free service. So you will lack something, and there will be some hallucination. Okay. Because they are trying to understand what I have to do. But next time, like you will ask something else and then something else, then again you will ask the same question. They will give you some different answer. So hallucination is there.
Yeah, I noticed that seriously. Yes, it
Yeah,
messed me up
because
seriously.
they are not agentic AI. They are not agentic. They are AI agents. See, there is a very different thing. What is generic AI? That is ChatGPT. AI agents, that Opus and all, they are the agents. Agentic AI, a group of powerful AI which can think, which can plan, which can take action, which can replan, and which can execute the things. That is agentic AI. There are three different tricks. Generic AI is something else, AI agent is something else, and agentic AI is something else. When there is agentic AI, means there is a powerful AI agent which is working in the group, which is working in the different segment, and it will give you the output.
You
Thank you
have to
very
give
much.
tools to the LLM. So you have different tools, and within the tools it will select, and for different tasks it will select. So that choice is given to the, like for Claude, it knows that it is strong in coding and giving us the code. So they
Correct.
have given trained the data in such a way, like from different source code like GitHub and all, so that they know which is the best practice and everything. And then they are giving it the tool also. Tool means what you saw, right? Like it can run bash, it can read, write, all those are the tools, and also to generate the code which is there. So all that is given to the agentic AI, so it makes it more powerful. So tools are required.
Yeah, and when
you
when
cannot
you are giving
execute
the skills.
anything. Yeah, it cannot execute anything. ChatGPT, if you tell do something, no, it cannot. It say I don't have the permission to execute, or I cannot. If you want to execute, whereas Claude will execute it for you.
Thank you very much. Clarified. Grateful, sir and ma. Thank you.
Anything else? Any question? Greg, I am very happy. You are always asking the questions. I am very happy.
Yes. He's only one, he always asks question.
Yeah, in the end, cohort, you are the only person who is asking daily. Even every session you are asking the questions.
And it's a very best practice. No, very best practice. I like it.
Thank you very much.
I will give you my marks. Whatever I'm going to get, I will give you.
Bhupender and Anuradha will get 100 marks, so they will
I will
share.
gladly receive.
See, understanding the things
but
and asking
Bhupender,
the thing is a best
but
thing.
Bhupender, Greg is, I mean, he's already enough to grab the marks, right? He can go anytime and present demo. He can get 100 marks. He's ready to present mine.
Yeah, so this is the thing, like be ready always, because I got some comment in my group. Someone is there, I won't take his name, I know his name. They are saying that we need some time to prepare. But see, when you are going in the corporate, you won't get any time. Your manager will say, okay, till the evening, I need this thing. If you will say, sir, I am not prepared, then he will say, okay, this is the last working day. So things are not working in the AWS. I'm attending the AWS session, and I'm afraid of the things like how they are working. If I'm not speeding myself, I will be behind, because they are not running actually. They are sitting on the jet and they are flying like this. They're zoom. They are not running actually.
We are trying to run.
So we are not. Yeah, and still we are not running. We are like doing that tortoise. Tortoise is walking now slowly, sir. We need a freebie. No, if you will,
The better
I
word is
will record
crawling,
the,
I guess.
sir.
The better
Right.
word is crawling, yeah.
Crawling, crawl.
Yeah,
Crawling.
yeah, crawling. We are crawling. We are not crawling, sir. We are not crawling. Even the baby is crawling. The baby is also having some speed. We are not crawling at all. I will
Even
record
the
a session. I will record an AWS session. I will share it with you, but don't share it in the outer world.
Yes.
Otherwise,
Okay.
No problem. No
all
problem.
right.
No problem.
but
Okay.
see what they are saying. There was a session and they were presenting that lambda function and all. A lambda function using
Function.
some yeah, a lambda function is there, and using lambda they are invoking the EC2 instance. I don't know nothing, and they are saying, okay, you have to execute that thing. But we are doing that thing because we don't know, but we are doing. This is the only way we will learn. If you don't know, just come forward. This is my request. Like if you don't know anything, if you are not completing your assignment, at least you can say, okay, sir, this is Sunday, Tuesday, we are having the demo session. Can we connect and can we prepare for that presentation? If you don't know, no worries, we are here. So we
And-
will tell you, okay, you can do this thing.
And
It will do
Bhupender,
nothing, but it will give you some confidence.
And Bhupender, we are not saying that just come, jump on and go and live. Okay. No, don't go and live. Just go with your commenters, take help and do a demo. Okay. Internally give a demo. Okay. After that, you can get confidence and you can go on live. You don't need to go directly go and live. Okay.
Because if you are not speaking here, you can't speak in interview.
Yeah, that's true.
You are behind the camera, you are not on the camera, you are just listening. It won't work. If you are not speaking, it won't work because you don't know how to speak. If you are very good in communication, but still in the interview, you can't speak.
Good talk, sir.
Okay, I guess we have another presentation.
Yes.
from the floor.
Who is there from Ranveer team? I think Wasima, right?
Sir, Vasima,
Tanisha ma'am is not
goodness.
presenting anytime.
Sorry?
She is not presenting. Oh, she is here. Hi.
Wasima is here. Okay.
So why I present when my group are presenting?
No, you
I
should
can
you should
also
present.
I can also
We can
present.
see you on the screen. You are like Eid ka chand.
No, one day will come, Tanisha will present.
सर मैं
Yeah,
तो
but
रेडी हूँ मैं तो आज का प्रेजेंट भी कर लेती कोई दिक्कत
No,
नहीं
no problem at all.
Very good, very good.
Okay. There are many good people in your team. So like Wasima and Ashu, Parthi, there are many people. Okay. So
Yes,
anyone
sir.
can present, no problem.
Goodness, Adidayo.
Yes.
We
There are
have a
many
lot of people.
Anyone can present anytime. I know it.
Yes, sir.
Sorry,
Okay,
my
guys.
bad. I'm one man army.
That's okay.
With Anu
That's
ma'am.
okay.
With
That's
Anu ma'am.
okay.
Okay, guys, please go ahead.
Yeah,
Okay,
yes, sir.
Wasima, please.
Yeah, I can see my screen, right?
Yes,
Yes,
we can.
Yes, we can see your
Yes, you
screen.
can see your screen.
So, good day, everyone. Today I will be working you through how to deploy a real production three-tier application in AWS. So, using Terraform for infrastructure as code and agentic AI to accelerate the whole process. The app we are deploying is a book review app, but with the Next.js frontend and Node.js backend and a MySQL database running on Amazon RDS. So let's start it. So you can see here three tier applications. So web tier, app tier, and data tier. So all of us, I think we have done this before previous week using AWS and Azure. So today we are going to use Terraform. So before we dive into the AWS details, let's quickly align on what a three-tier architecture actually means. So there are three distinct layers. So the first layer is called web tier, and it is the similar like presentation layer. And it's the Next.js frontend running on Ubuntu virtual machine with Nginx, sitting in a public subnet and accessible through a load balancer on port 80. Then comes the app tier. This is the business logic layer. Node.js backend runs here on port 3001 in a private subnet. It's only reachable from the web tier, not the public internet. Then finally on the data tier. So this is our Amazon RDS MySQL database, also in a private subnet. And with multi-availability zone deployment and a read replica for resilience, the key principle here is a solution. Each tier can only talk to what it needs to, and which gives us security, scalability, and clean maintainability. Then let's go to the next slide. This is the AWS architecture. And this is how real production setup look like. So architecture shows the full picture of how all these pieces connect on AWS. So you can see here on left, user traffic comes in through the public application, load balancer, hits to web tier virtual machines, and then routes internally through an internal ALB to the app tier. The app tier communicates with RDS MySQL in the database subnet. Private instance use a NAT gateway to reach the internet for updates without being publicly accessible themselves. Everything is spread across two availability zones for high availability. So we have done similar to these in our previous week. So you can recall your memory there. And let's go to the next slide. So this is AWS key services. So it's familiar to everyone. Let me quickly walk through on it. This first VPC and subnet. We define a custom network at 10.0.0.0/16 with 6 subnets across two availability zones covering the web app and database tiers. So then next one is the security groups act as firewall rules. The web tier allows HTTP on port 80. The app tier only accepts traffic on port 3001 from the web tier. And the database only accept MySQL on port 3306 from the app tier. Then the next one is the public ALB. This distributes incoming user traffic across our web tier virtual machines. Then the next one is the Then the next one is the NAT gateway. Allows private instance to initiate outbound connections like pulling updates without being reachable from the outside. Then the next one is the internal ALB. Internal ALB routes traffic from web to app tier internally and keeps app servers off the public internet. And finally, Amazon RDS MySQL gives us managed multi-availability zone database with automatically fail over and read replica all in private subnets. Then let's come to this. So here is the detailed subnet breakdown. Here we have consider African South as the availability zone with VPC CIDR of 10.0.0.0/16. So, and also we have 6 subnets total into this assignment. 2 public subnets for the web tier and each availability zone like A zone and the B zone. And then 2 private subnets for the app tier and 2 private subnets for dedicated to the database. Each tier spans both availability zone, zone A and zone B as I mentioned. And also the other keeps everything running. Public subnets route outbound traffic through the internet gateway. And private subnet route outbound through the NAT gateway. They can reach the internet, but internet cannot reach them directly. Then let's go to the next slide. So this is the interesting part. So this is very important to the assignment. So now we are using the Terraform instead of clicking through the AWS console. So for there is 4 reasons, and it's like prawns to this. It's repeatable. You can deploy the exact same infrastructure consistently every single time. It's version controlled. Your infrastructure lives in Git just like your application code. It's automated and no manual steps, no human errors from clicking. And it's auditable. Every change is documented and reviewable. on the right, you can see the actual Terraform resources we are defining. VPCs, subnets, gateways, and security groups, load balancers, EC2 instances, and RDS. So every single AWS resources in this architecture is declared in code. So that you can see in right side. Let's go to the next slide. So this is where the things get interesting. So traditional DevOps means like writing all your Terraform manually, searching docs for every resource, debugging errors by hand, and reviewing security rules yourself. It works, but it's slow. So with agentic AI in the loop, you can generate Terraform template instantly, get AI-powered explanation for errors, and also receive best practice configuration suggestions and have your security group rules validate automatically. The iteration cycle becomes significantly faster and more configured. And importantly, agentic AI is recommended for this assignment, but not required. If you don't have Cloud Code, you can use ChatGPT, AWS Docs, or any other available agentic AI. Then the next one, Cloud Code. So here we are going to talk about the files. And for those using Cloud Code specifically, here how it's structured. And like these things are maybe familiar for some and for some not. So you start with Cloud MD file. So here this define your protect content goals and constraints. So Cloud understand your infrastructure before it does anything. Like basically you are telling all the requirements there. And then you have skills, pre-built expert capability for Terraform, AWS networking, and security group review. And the sub-agents. Sub-agents list your delegate subtasks in isolation. One agent generate your VPC code and another review security, another debug error. So I will give an example here for skills and subnets to keep in your mind. So skills is like when we take the examples DMI. So skill is DevOps, that you are learning DevOps. But the task, who is assigning the task and the work to you, like co-mentors and the team leaders, the co-mentor here, and then the co-mentor become the sub-agents. So actually I learned this from Bhupender, like he was explaining this. So yeah, that is easy way to keep in your mind skills and what is sub-agents. And the final one is the MCP tool. So MCP tool is connect Cloud directly to AWS, GitHub, and other services in your workflow. Some examples like prompt use, you can use prompt, generate Terraform, VPC for 3-tier applications, and debug this Terraform error, or review my section, group rules, and so on. And let's go to the next slide. So this is, if you are not using Cloud Code, there are excellent alternatives like ChatGPT can generate Terraform templates, explain errors and suggest architecture improvements. Then AWS documentations also. Ground truth for every services and best practice, the Terraform docs and registry at Terraform. Also you can use, but its Cloud Code is interesting and it will help you to build your career in future. So you can use Cloud Code. If it's not, you can go with the alternatives. Then the final one, what we are going to cover in this assignment and what we have to submit in this assignment. So you have to deploy full stack app on AWS and design production networking and automate with Terraform, and work with agentic AI and build security best practice. So let's go to the demo session. I will hand over to Goodness and Mary. So over to you. Thank you for listening.
Well done, CT. Nice presentation.
Thank
So I
you.
will be doing the demo for the deployment of the book review app. So as you can see from our assignment guide, you can make a choice between your favorite cloud. So we'll be going with AWS. And you can see the project requirements. We've deployed a book review before. So it has 3 layers: the presentation layer, the business layer, and the data layer. And by completing this assignment, you should be able to deploy a full stack cloud application using Terraform. So using agentic AI is recommended, but it's not compulsory. And for this deployment, we actually did the manual deployment because we wanted to build it out first. And at the end of the day, we didn't really have enough token to use cloud code. So we created a repo for this. Then the technical requirements, you need 6 subnets in 2 availability zone, that's for high availability. Then for the security groups, you have the security group rules, the web tier, app tier, and database. And for the VMs, which are instances, you have the web tier, which is the web server running on Nest.js, and
You're
the
not
app server.
presenting, I think. Your screen is not. Yeah.
Sorry about that. Sorry about that.
Let's share the screen.
Can you see my screen now?
Yes, we can see.
Okay. Let me hide this. Okay. So I'll just go to my GitHub because we deployed the Terraform configuration files, and I'll just explain what each module does. So this is the repo Terraform book review Terraform IAC. So Terraform is an infrastructure as code. So if I go to the README, you can see how we went about this deployment. So this is a 3-tier applications, just like CT explained. It has 3 tiers. It has the web tier, the app tier, and the database tier. So traffic flows through the public load balancer from the client to the public load balancer, which serves traffic to our app tier, to our web tiers, that is our web servers in the public subnet. Then the load balancer, the public load balancer also routes traffic to the internal load balancer, which accesses the app servers in private subnet. Then the database layer only communicates with the app server. So it's in a private subnet, so internet access is not allowed. Then our project structure. So we have a file structure which contains our Terraform configurations, the main.tf, variable.tf, and output.tf. So we have a root main.tf, variable.tf, and output.tf. And we have the Terraform variable, so it's stored in TFVars. So this is excluded from the Git repo because you don't commit your TFVars because it has sensitive data. So you ignore it with a git ignore. Then we also have a deployment guide because we actually used a script. We use a script for this deployment, so you don't really have to go in and run all commands manually. So when you get to the app deployment, we're going to deploy it with a script. Then for the modules, we use modular infrastructure, that is modular Terraform. So each layer of our infrastructure, the networking, security, compute, load balancing, and database. So each layer is built separately. So we down call them into our main.tf using modules. So it's a separate block. Modules are a separate block. So you can see for each module, we start with the networking module, just like when you create when you create on AWS, you have to create a VPC first. So once you create a VPC, from the VPC, you create the subnets, the private subnet, and internet gateway, NAT gateway, route table. So once you create the VPC, you now move to the security, which is your security group rules, public load balancer, web servers, and internal ALB. So you create the security group. And before you can do this, you have to already have your EPC, that's your networking setup. Then you create your EC2 modules and your load balancing modules. So it was actually fun collaborating with Mary and Ade for this project because we actually learned a lot. And in case you have been asking how we came about these configuration files, so you don't really have to like remember these files. You can just go to like the AWS provider for Terraform because we are using AWS. So you just search Terraform AWS provider. So once you get to Terraform, you can just click on the link and you can search for any resources. You can search for VPC, any of them. So if you scroll down, you can see an example. So you define your provider, which is AWS. So you just copy this and you edit. We also use generic AI to generate some of the configuration files. So in case you've been wondering how we came about that. So with this, I'll just go into my terminal and I'll clone this repo and we'll deploy the infrastructure. So I'll just copy the code. Then go to my terminal. So let me just open it up in VS Code. So you can see our file structure for the book review. We have the modules and we have the root main.tf, output.tf, and variable.tf. I don't know if Ade is here. Ade can explain the file structure because we actually collaborated on this. Ade?
Thank you very much, Goodness, and thank you,
Okay.
City, for that wonderful presentation. My name is Aaron Totayo, walking you through the project structure. So now, so many of you will ask, why do we choose modular Terraform infrastructure? The reason why we choose modular Terraform infrastructure is to, one, avoid chaos. So without modules, everything sits in one file. As you can see, the previous demos shows that if you put all the Terraform scripts inside one file, it is difficult for you to track any issues. Maybe there's any errors, there's any bugs. It's very difficult to track it. So we use modules to avoid chaos. So everything sits in different files, like the different modules sit differently from different, like each other, like from different files. So that's how we use it for separation of concern. So hundreds of lines of codes are mixed together if we use one singular main.tf. And also Terraform script becomes hard to read and very hard to debug. So with modules, we are able to do them in their own space. We have different blocks for different modules. So they are in separate layer, they are not mixed up together, there's no chaos, there's nothing. So every modules are in separation from each other. So also it is easy to read and locate issues. So when you run maybe your Terraform plan or your Terraform apply, and there is any issue, you'll be able to trace it back to the module that the error is coming from. So that's why we use modules. And another reason why we use modules is for reusability. So we use modules because we can reuse modules in other projects. For example, now maybe we have another project in maybe during next week class, we have another project and want to use, instead of building all our VPCs, all our networkings, all our security groups from scratch again, you can just use the predefined modules that we define in
Goodness
this
present कर रहा
week's
है और
assignment.
Adrentino वो present कर
Huh?
रहा है.
Can you hear me?
Hello?
Yeah, Aditya,
Hello?
you are presenting?
Yes, we can hear you. We can hear you.
Okay,
Okay.
I'm just explaining the project structure. That's basically what I'm saying.
Yeah,
Okay.
sorry.
All right, so I'm explaining why we chose the modular infrastructure in Terraform. So that's what I'm explaining. So as I'm saying, we chose modular infrastructure because of the reusability. You can use modules in any other project that we have in the future, any other subsequent projects that we have. So you can be able to reuse our networking module in another project. So we don't need to write all these VPCs, internet gateway, subnets, and routing. We don't need to write them again from scratch. We can just use them, reuse them in any other project that we have in the future. So another reason we use modular infrastructure is scalability. So as the project grows, you can add more resources, you can add more complexity. Like the project can become more complex. So it will allow us to add different other modules without affecting the foundational modules that we have in this project. For example, now we are in this module, we have ALB, we have networking, we have database, and we have security. So in the future, maybe we want to add another gate to, like, maybe network balance, load balancer, or you want to add any other modules. For example, you want to add Kafka, you want to add any other resources. You can just create a new modules and add them to the foundational modules that we have. So it allows scalability and allows us to add new components without breaking existing ones. So another reason why is for team collaboration. As Goodness just said, that we collaborated on these projects. So what we did is that Mary took one of the modules, Goodness took one part of the modules, and also took part of the modules. So it allows collaboration, team collaboration. So one person can handle networking, another person can handle compute, another person can handle database. So that's basically how we were able to come up with this modular Terraform infrastructure. The next one is we can have a cleaner and more professional code. So our modules are well structured, they are easy to explain and easy to maintain. So it does not cause any confusion. If you are, maybe there's any new member in the team, you can easily explain to the new member that, okay, this is the module for ALB, this is the module for networking. So it is clean and more professional. So that's the reason why we actually chose modular Terraform. So now the project structure, we have the modules, we have the networking module, we have the security modules, we have the ALB modules, EC2 modules, and database modules. And we also have the root files. We have the main.tf, the variables.tf, the output.tf, and the terraform.tf vars. So now, what does each of these modules stand for? The networking. The networking contains our VPC configuration, our subnetting, our route tables, our internet gateways, and our 6 subnets that we have, the 2 web subnets, the 2 app subnets, and the 2 database subnets. So that's where we wrote the script inside networking main.tf. So that's where all our networking configurations are placed. Also, in our security group, we have main.tf, we have output.tf, and we have variables.tf. So in our security modules, that's where we put our security group rules, all the public ALB security group, internal ALB security group, WebSG, and AppSG. That's the place we put our security groups and their rules. So it allows separation of concerns. So one module is not affecting another module. So the next one is ALB module. ALB module contains our load balancer, our internal load balancer, and our public load balancer, and where we declare our traffic routing policies with target groups and all other routing policies. Now our EC2 modules, that's where we have our instances, like our 2 app instance, our app instance and our web instance. So everything is in our EC2 modules, and we declare our variable, our RDS database inside our database module. So what are the things we have in the root files? We have in the root file, we have main.tf. The main.tf in the root file is a control center. It controls what other modules in our project structure. It controls what they do, and it connects them together. So for example, now we can pass, when we work with our networking module, we can pass info that we use in our networking module inside EC2 module through our root main.tf. So that's basically the work of main.tf. It connects all other modules together. So that's basically the work of main.tf. And also variables.tf in the root. Variables.tf is where we put our variables, like, because we use variables in our project. So all the variables that we declare in each of the modules, we call those variables again inside the root variable.tf, so that the project can use them when it is time to apply all our configuration files. They can fetch the variable names, the default settings that we applied in our variables.tf, and also output. So the output we want in our from our resources deployed on AWS or any cloud environment, we can put it in our output.tf, our root output.tf, like the load balancer URL, the database endpoint, the EC2 instance, public IP, private IP. So this is where we put our output. So the Terraform.tf vars, it helps us to assign values to each variable that we have declared in all the modules. So for example, now in our Terraform.tf vars, we declare our CIDR blocks, our VPC CIDR, our subnet CIDR blocks, and our database name, database password, and all the variables that we need for the deployment to be successful. So that's where we put our Terraform.tf vars. So modules helps us to break our code into manageable pieces instead of writing a very long
main.tf
Terraform scripts. You can break them into manageable pieces that each and every member on the team can actually take up and manage each of these pieces. For example, now a member of the team can manage networking, a member of the team can manage database, and so it allows us to manage all these pieces together. Guys, connect everything together, like our root, our main.tf, variables.tf, and output.tf connects all our modules together and brings all about a successful deployment. Also, this modular approach makes our project more cleaner, scalable, and reusable. Thank you all for listening, and I will bring Guinness back for the deploy and demo presentation. Thank you very much.
All right, thank you very much, Ade. So just like Ade explained, we have different modules for various blocks. So we have the security modules, the networking module, and all other modules. So, but once you clone this repo, if you go through the file, you can see that there is no .terraform. So if you ls -al, you are not going to see .terraform, because that tells you that this whole repo, this whole folder, it's not initialized to use Terraform yet. Let me close the chat, sorry. So it tells you that this whole repo is not initialized for Terraform yet. And if you go through the README that we created, you notice that we also need to create a Terraform.tf file. So all the variables that we've defined, all these variables that we've defined, region, CIDR blocks, like all these variables, we have to call them. So for that, you have to add the Terraform.tf. So, and it's already here in the README. So if you go through the README, the first step or the second step, let me take it from the web version, which is clearer. So if you go back to our README, so first of all, the prerequisite, you have to have Terraform installed and you have to have configured AWS CLI. So then you create a key pair. So we'll come to that. Okay, let's just follow it step by step. So first of all, we'll create a key pair. So don't create your key pair in your repo because key pairs are also private. So you just go to open another terminal and let's go back one folder. So here, maybe we can create a key folder. Let's say AWS key, mkdir. So inside this key folder, we'll just create our key. So, but if you have a key pair, then you don't really need to like create a new key pair. So if you have a key pair, just use your key pair. But if you want to use a new key pair, so you have to create it first. If not, once you do Terraform apply, it's going to fail because the key does not exist yet on your AWS. So to create the key from your terminal, you just use this command AWS, sorry. So AWS EC2 create key, that's like a CLI command. And you put the key name. So you put your key name. Let's name this key infra. Let's just name it infrastructure. So infra. Then the regions. Keys are region specific. So any region that you're using, you have to create the key. You have to pick that region. So if you don't pick a region, it's going to select your default region. So the default region that you configured your AWS CLI, that's the region it's going to use. So for this key, since we are going to deploy in US East 2, that is the Ohio region. So we'll just pick that region. Then for the key material, so this part, if you create your key on AWS, you have to download it. So this part.
Hello? Babe, I'm okay. How are you?
Okay, for this part, you just
What office
create the
send it?
name that you store
Yeah, emote
locally.
yourself. Oh.
So infra.pem. You don't need the ch. Maybe I copied or some stuffs. So once you create your key, you can see it has created. So to confirm this, you have to ls. And even if you create your key, you still need to give it a ch mode. So without a ch mode, it's going to tell you a public key access denied. So you still need to give it permission. So you do a ch mode 400, then the key name infra.pem. So with that, we have created our key. Now we'll go back to our terminal for Terraform and we create our terraform.tf files. So that is where all our variables that we've called will be stored. Terraform.tf files. So we use Tosh. Oh, I think let me do that again. I'll just rename it. MV Terraform CFS. Okay, you can see it now. So it gets ignored. That's why you can see that the color is faded because it's not getting pushed to our GitHub. So if you go to the README, you can see the TFR sections where we declared all the variables that we have in this infrastructure. So you just copy it and go to our TFRs and paste. So you still have to like edit it. It's not plug and play. So for the region, we are using ES is 2. Come, let me zoom out a bit. US is 2. Then for the project name is book review. You can change it to book review app. Then for our CIDR block, so our CIDR block is 10.0.0/16. So then our subnet, we have 6 subnets, which is web, 2 app, and 2 database subnets. Then we have the instance. So you have to define the instance type. Just like when you are creating when you are creating on AWS console, you define your instance type. And we got, if you go back to our EC2 module, you can see where we call this variable instance type. You can see var.instance type. So you have to define this. You have to come back to your TFVars. So that is where we get all these variables. So all these, you can see var.web subnet ID. So all these things, we have to define them in your Terraform.tfvars. So you just scroll down our app instance. So we are going to name it. We are going to use T3 micro, not small, because it's free tier eligible. Then our key name, we created infra. Let me confirm the name again, because it's case sensitive. Yeah, infra.pem. So you just name it infra. The .pem is the extension. Then for our data, our DB name, the DB that is used by our instance, by our database is book_review DB. So you can actually give it anything. But since we are using a script, we define this in our script. Then for engine version, we are using 8.4, which is the latest version. And our user is admin, while our password, we have a very funny password, which is byte token, so that you can use cloud code byte token. Okay. With that, we've defined all our variables. So this is all the variables that we have here. We've defined it. So you now come to your terminal to initialize your Terraform. So you do that with Terraform init. So what it's doing is it's going to install all the modules that we have from the ALB database networking. It's going to install all the modules, and it will create a .terraform. Yeah, you can see it, .terraform. So this tells you that, okay, this folder is initialized to use Terraform. So this is actually going to take some time. So we'll just have to wait. But while we're waiting, you can also use the AI integrations. It's generic, so it's a chatbot. It's not like your cloud code that you can prompt directly. Okay, this one is ready. We'll come back to this. So we'll do a Terraform plan. So Terraform plans will actually, okay, first of all, we'll validate to check if we have any error. So you have to validate first. So if anything is going to fail, it's going to tell you from here. So once you validate, in case there is a syntax error anywhere. Okay, you can see that our configuration is valid, so it's successful. So we can now do a Terraform plan. You can see it created the Terraform TF state, just like our co-mentor was talking about. So you can see all the resources that will be created here. So it creates from models, just like Ade said, models make it easier to track errors. So in case you have an error with a model, if there's an error here now, it's going to pick and we'll know where to go to. So instead of having one long configuration file, you break it into different blocks. So there's no error, so we'll do a Terraform apply. Terraform apply. So you can either do Terraform apply auto approve, or you can just do Terraform apply. So with Terraform apply, you get a chance to see everything it's going to deploy. Instead of when you use auto approve, it creates automatic, so it's not going to prompt you to confirm. But if you just do a Terraform apply, it will prompt you to confirm. So just do a Terraform apply. So it will start deploying our, yes, it's now going to ask us. So it's going to prompt us, do you want to perform these actions? So all the actions, it's going to, you can see for the VPC, it's going to create a CIDR block, a default network ACL, default route table, and it has host name enabled. You can see it's true. So it's going to do all this. And it will tell you 46 plan to be added, 0 change, 0 to destroy. This is because this is the first time that we are applying. So if you make any change and you apply, it's not going to delete those. So it will just update the changes. So for this, since it's the first time, we'll just type yes, and it starts deploying. So you can see it's creating the VPC modules first, because that's the networking. Then you see everything that is creating module by module. You can see it's creating the security group. It's still creating the security groups, because we have different security groups. So once it creates, it's going to output. It's going to output our web server public IP. Then it's going to also output our private IP and our database endpoint. So because we'll be needing some of this for our scripts, because we have a deploy script. We've deployed book review for a couple of times now. So instead of going to manually run all these commands, we have a backend deploy script. If you go through it, it's just like our co-mentor Bupenda was explaining earlier. But for Bupenda's case, they used user data, so they bootstrapped it from the point where the instance was starting. But in our case, we are going to go in and run the script ourselves. So we have to jump from the web server into the app server. Then we'll run the backend script. And also on the front end, we're going to run the front end script. So for the script, you have to edit it. So you have to edit the DB host. So once you have your output, you come here to edit this. So you create this script in your terminal. That is in your web server for the in the app server for the backend script. So you create it in your terminal. Then you update the resources, that is the details. Like for our DB hosts, we have RDS endpoint. Then password, we have RDS password. And for allowed origin, so we are allowing origin for our public load balancer. Then because we've defined all these variables that you are seeing here, DBOs equals to, we need them because we've defined it here. For our .env, you know, when we're deploying book review manually, like we had a .env that will always go to edit. So you can see our DB host, which is our RDS endpoint. It's going to call that variable that we defined. Then for our password, we also have to define it. The rest are the same. You can see book review, you can see our username admin. But if your username is not admin, then you have to edit this. Our application port is on port 3001. And so we also use Echo. So what Echo does is Echo prints to your terminal. So at every stage, you get to know what is happening. So you can see after editing our .env, we installed PM2. So Echo will print that to your terminal. So you see what stage the script is running at. At every stage, we have an Echo that displays what is running. Then at the end, you can see the Echo deployment complete. Then it's going to print out the PM2 status. So you are going to see your backend online if there's no error. Then at the beginning of the script, you can see we have the shebang. That tells you that it's a script. Then we have the set EUO. So what this does is, if there's an error, maybe an unset variable, so everything fails. So it doesn't continue running the script. So everything is going to fail at that point. That's what this does. So once our application deploys, we are going to SSH into it and deploy our application with a script. It's not going to take time. It's going to be very fast, and instead of running everything line by line, so just wait for it to create. It's creating the database, and we all know that database takes time to create.
Can you show me that terraform.tf file?
Okay. Terraform.tf. Sorry. This is where we defined all our variables. We're going to minimize this.
Now, can you show me that module EC2?
Okay. These are EC2 module, our
Main
compute
file,
module.
main.tf.
Yes.
Yeah.
We have all
Scroll down.
You can see our resource AWS instance. So we got all this from the Terraform documentation. So you have to define the name, then the resource name. So for the app server, we define it. You can see the AMI, the instance type.
No, that is all good. That is
Yes,
all
we
good.
declare it as a variable.
That is all good. What I want to ask you is, if you are having main.tf file here, why you are creating terraform.tf files? You can write all that value here only, na? Why you are creating one extra file? There is a code complexity again.
Yes. So why we create the Terraform.tf file? Because when we clone this repo, we had all our config, but then we don't have the variables defined, because variables it can contain sensitive data. So this is just on my local. Even if I push this back to GitHub, it's not going to contain all this. So it's just for the sensitivity. You create your Terraform.tf, your var files, you have to git ignore it. So that's why.
Great.
Yeah. Okay, our deployment, that is our infrastructure deployment, is complete. Just like I said, you can see all our outputs that we'll be using for our scripts. So we have the app server private IP, because it's in a private subnet, so it doesn't really have a public IP. So it's a private IP, and with the private IP, you can't really get into it directly. So you have to either use a bastion host or a jump server, or use AWS console, that is the client, the SSM client. Then we have our endpoint, which is book review. You know our endpoint is, this our RDS endpoint. You are not going to copy it with the prompt, with the port. You just copy it with to .com. Then we have our private load balancer. So our private ALB is an application load balancer, because we are going to use this for reverse proxy. And we also have our public ALB DNS name. So we'll use all these. Now we have to just SSH into our terminal, and we deploy the backend and front end. So using the script. So to do that, you copy your front end IP, just like we do on AWS. So you go to a new terminal, and this is where we have our key. In case you don't have your key here, you can call it from anywhere, as long as you know the location of your key. If I do pwd, it's going to print my working directory. So I can actually call this. If I create a new terminal, you can see that it's going to be in my Terraform folder. So I can call this, because I know the location. I'll do SSH-I. So before we do SSH-I, we have to copy the key first to our, we have to copy the key to our web server because we're using our web server as a jump server. So without that key, we'll not be able to like get into the app server. So we'll first of all copy it. So we use secure copy SCP-I. Then the key name. So I know the location of my key, which is my home directory. Let's check it again. So from my home directory is demo infra, then AWS key, demo infra, AWS keys. Then the name of the key, which is also infra.pem. So we are copying the key, but before you copy the key, you have to indicate your key first. So because we are using infra as the key to our web server, that's why infra is here. So it's going to be as if we are repeating this twice. But in case your web server key is separate, then this is not going to say, in case someone will see it and feel that, oh, you have to copy it 2 times. No. The -I, what comes after -I is the key that you are using. Then what comes next is what you are copying. So we are copying, you still go to the you call the absolute part because we are not in the file, in the folder. So you call the absolute part demo. Okay, let me sorry, infra.pem. I used tab to autocomplete, so we'll go back again. Demo infrastructure. So it's using the absolute parts, AWS keys, then the name of the key. So we are using one key for both our app and web server. That's why. Then the IP address. So where are we copying to? We are copying to our web server. So this is the web server IP address. First of all, you have to put the username Ubuntu, which is the default user, at the IP. Then the location. So we are copying to .ssh. /.ssh. So this is a hidden folder in our home directory. So once you copy, so it's going to ask you, are you sure? Yeah, you say yes. So it's apparently added our IP to our host. So you can see 100%. That means our key has copied. So this was possible because our security group allows access from here. That is from where I am now. If your security group does not allow access, then it's going to get denied. Or if you don't have like the right permission, if you don't chmode it to 400, it's going to fail. It's going to tell you public key denied. But since we have it, we can just copy it. So from here, we SSH into the web instance. So it's do SSH-I. You call the key. Because I know the location, I'm going to call it directly, demo infrastructure, infra AWS key. Then the name of the key, infra.pem. Then the user Ubuntu at the public IP. You can see that our IP has changed. So we are in our web server now. This is the private IP of our web server. You can see it here. So from here, we jump into our backend. So we are going to deploy the backend first before we deploy the front end. So we are going to jump. First of all, let's see if our key is there. Use ls, then the folder ssh-i. Okay, sorry. ssh.ssh, sorry. You can see that our key is here, infra.pem. So from here, we jump into our backend, ssh-i, backend. Just go to our outputs, private IP of our web app server. So you just copy it. ssh-i. First of all, you have to, after I, you have to define the key. So point to the key infra. Okay. The key is in .ssh. It's not in our home directory. That's why it was not there. So we are going to do dot SSH slash the name infra. Okay, this capital letter, sorry. So once you get the name, you just auto complete with your tab key. Ubuntu at then the private IP. So it's going to ask you because it's the first time, then you say yes. So we are at the app server now. So the next thing to do is we are going to install our script. So when we're doing it manually before we update first, then we install the dependencies. So all that we are still doing the same thing, but this time we have compiled all the command into a script. So you create the script to deploy, nano deploy, you create the script, deploy backend .sh. So your script must end with .sh. That's what makes it a script. Or you can give it any name. It doesn't have to be backend, deploy backend.sh. So we'll copy the script. I've gone through it already, so but we'll go over it again because we have to replace the variables that we defined earlier. So we are going to replace our database host. So you can see you replace it with your endpoint. Yeah. Okay, that's to be in quotes because it's a variable. So you come here, you copy your book review endpoint. Remember, you're not going to add the port. Just copy the endpoint. Then you paste it. Okay. Oh, sorry. Pasted outside the quote. So then our password. So our password is by token. You can copy it. You can go to your TFR and confirm because it's also case sensitive. You go to your TFRs, you can see password where that's the last thing that we define by token. So it's a capital B and the token starts with a small t. Okay. Then your allowed origin. So this is actually very important because the app is running with cross-region resource sharing. So you have to add it in your environmental variable. You just copy the DNS name of your load balancer. This is the public A or B. Copy. Okay. I think that's all for our backend scripts. So if you scroll down, you see where we called all these variables that we defined. So you can see our database, host, admin, password, and DB name. So the port is 3001. So if you don't have a port, it's going to run on the default port, which is port 5000 for this app. Then the allowed origin. So when we're doing it manually, you have to select the HTTP because we are using HTTP. So this is where we defined our origin from. So after the HTTP. So in case so don't get confused on that. So we save and exit. So if you ls, you're going to see our script, but you can see that it's plain. That's because it doesn't have execute permission yet. So you do a chmod u plus x. So the x means executable. Then the name, deploy, tab. So if you ls again, you can see that the color has changed. Now it's a script. It's executable. And to run a script, you just do / the name, deploy. So you can see that it's installing now. Just the same process that we normally do. You will see, and the echoes that we added, it's going to tell us at every stage what is happening. So at this stage, it's installing. Anytime you go into a server, you have to update the server so that you get the latest files. You can see that now. Look at our echo is installing Node.js now and the dependencies. So at every point, it's going to show our echo that we defined. So now it's cloning the repo. And it has created the .env. And you can see our PM2 backend, book review backend is online now. So we did this under 5 minutes. If you are doing this manually, you know that you have to run the commands step by step. But now we have done everything at once. So to confirm that we have everything, you just do PM2 logs. You can see our database schema updated. The sample book has been added. Sample book, a sample user added, sample book added, and sample review added. Then server is running on port 3001. So why we are getting incoming requests from undefined is because our load balancer performs health check. So we have not set it up yet. That's why it can't really recognize this. So if we go to let's SSH back into our web server and run and configure the script for our web server also. So you copy the IP address of your web server, or you can do this also, Ctrl+C. You can exit the app, but first of all, let's test it first. So if you go to the projects, the book review repo, sorry, book review. So that is from Pravin's repo. So if you go to the backend, there's a way you can test your API calls. So I noticed that a lot of people deployed and their books were not showing. So you can test that now after configuring your back end. So you first test on the local host. So API gets book. Good. Perfect. So once you run this command, you're supposed to get a JSON file of your books. You can see all the books are here, the pragmatic programmer, the author, everything is here. So if you go to your front end, you can also test this. Let's go to our front end. Let me clear my screen a bit. So if we exit, we'll go back into our front end. Then we can check if our app server is reachable from the front end. So you are going to replace localhost with the internal load balancer, because that is how our traffic flows. You cannot reach the app server directly from the web, so it has to go through the internal load balancer. So you copy the IP, the DNS name of the internal load balancer, copy it, and you paste. So you are supposed to get the same response that you got on your back end. So you can see our front end and back end are communicating. So with that, we can deploy the front end. So clear, same process, nano, our front end. So we can actually name it anything. It don't have to be deployed front end script. So just name front end.sh. You can, if you want to add line number to nano, you just do Alt N. So we don't have anything here yet. But once we paste everything, you see that it has line number. Okay, so copy everything and we paste. So you go to the beginning. So we have our variable. So require variable. If you don't do this, it's going to fail because we call these variables in different places. So we call this on our .env.local, our public load balancer ALB. So you have to update it. Go to your .env public load balancer. So you copy, then you paste. Okay. Then your internal load balancer also, because it's needed for our engineers. You know, we configured engineers reverse proxy. So you have to configure that also. Internal ALB. Copy. So insert. Okay. So let me just take you down. You see where we call these values. So after you have cloned, you have installed engineers. So you can see the $sign. This is a bash script. So it's saying, okay, this is a value. I don't know if when we did WordPress with user data, where we're having issues, if you use $sign, you experience some issues, your password of selling, because it's the way the shell treats $sign. So if you have $sign on your IP, it's actually thinks that it's a variable. So we are calling it public ALB here in our next API. You know, when we configure our env.local, we put our public ALB there. So that is why it's there. Then if you go to our nginx proxy, you can see our server listing on port 80. Server name, we use slash, so it picks all server. Then the proxy pass, that is the location of /API. If you don't have this, your app will load, your website will load, but it's not going to, you either see no books or you'll not be able to register. So also on line 103, you can see our origin. This is because we use cross origin resource sharing. So you put our public load balancer there. I think that's also, it's just like the backend script, it prints everything that is going on. So we save and exit. Then if you ls, you see that it's plain because it's not a script yet. You have to chmod it. U plus X. Then the name, front end. So if you ls now, you can see that it's going to be colored because it's now executable. So /front end. So you can see updating system. So it's going to do all those commands that we've run manually before. It's going to run them all at once. And once it's done, we just go to our load balancer. And you can see that you should be able to register and you should be able to leave a review. So just wait for it to complete.
And in case you still want to use the Cloud Code terminal, you can still drop a script about it or a document about it. It's just still the same commands, just like Cloud Code uses /tf apply /tf plan and every other thing.
Yes.
So
Yes,
you can also create. a script for it, like /deploy, the script we have here for the front end and also the back end. So it's just the same process, just same command, but different way of writing there. So you can also drop a documentation about it later if you want to use that format as well.
So it's installing the front end dependency. So it has to install the Next.js npm. So it's going to install all that. So it has cloned the repo. Once it clones, it's going to move into the repo, because if you remember, you have to edit do your npm install from the repo. So it's going to create everything all at once. Our front end is running on Next.js. So you can see that, yeah, so you see how it goes. When we're doing it manually, you see every stage as it goes. So it's the same process, just like everything now. What a script does, it compiles everything that you do, just compile it into a script. And in case you are wondering, oh, there are some places where we had to like configure our nginx proxy and the rest. If you go to our script again, we use end of file. So what end of file does is, when you use end of file to cut a command, it's going to keep the structure. So it's going to keep the syntax intact. You can see EOF, end of file. So it's going to keep the syntax as it is. You know that nginx has like a syntax that I use. Our app is running, it checks the status, and if you scroll up, you will see deployment complete. So if we should test now, let's do config. So because it's going to maintain the syntax that we gave it, because we use end of file, you see that there won't be any syntax error. Test is successful. So what is left now is to go to your public load balancer on your browser. Go to your browser and let's see. You can see our app has deployed. You register. So I'm going to register with my teammate names. First of all, it was CT. Then maybe as we proceed, goodness. Then we have Mary. She said I should not call her Mary. It's Mary. Then we have Ade. Okay, Ade comes before Mary. Sorry, Ade and May. Because Mary is going to like walk you through how to do all this with Cloud Code. So just like a summary, then we can create our email. You can use any email. Then our passwords. Okay, let's still use buy token. So if you buy token for us, we'll also show you how to deploy using Cloud Code. So you can see that our registration is successful. So you save. Then if you go to login, just use the password that we created. You can see our app. Then you can leave a review. Let's say any review, wonderful read or great read. So you leave a review. You are going to see our name, City, Good, and Ade. So that's it. We've deployed our server without going to AWS console, all from our terminal. So if you have any question, you can call me now. And if there's time, I think Mary can also give a brief review of how to like walk through the Cloud Code if you are using Cloud Code for this deployment.
Yeah, I can just drop a documentation about it because my system is going off already.
Okay, no problem. So you can just reach out to us if you want to use Cloud Code for this. We'll also walk you through. Yeah. So I think Greg has a question.
Yeah, goodness. That was a lovely presentation with you and your team. I think thumbs up to you. Mary, thumbs up to you. I think there's one person. Okay, thumbs up to the last person. I think your automation was creative, at least. Having to do this form of scripting when for automation. But one question I have is this. Maybe everyone has forgotten it. How do you go about job posting without it failing? Because I know basically you're job posting because your app tier or your other web tier is private. So the question is, sometimes people will try to want to jump post and it doesn't work. So what's the guide? What are the things you actually check physically so that by the time you're getting to that job posting, it doesn't fail?
Okay, if you are jumping from an host, let's say you want to jump from your web to your app, so you have to define it first. So the security group must allow that through for it to exist. And sometimes when you copy your key to your web server, maybe you have not really given it that permission, that chboot 400. So if you don't give it a permission, it's going to tell you public key. Or you don't have, like, you know how we route traffic in security group to security group. So either the web server SG is not aligning port 22 yet, or you've not defined it yet. So that's just the reason why it fails. So in a production environment, you don't actually use jump host, you use bastion host to do that. Yeah.
Thank you very much.
Yeah. Any other question?
Nice presentation.
Yeah, thank you.
Sorry, Seti,
And,
well done. I just remembered your last group person, Seti. Well done, too. Lovely presentation. Sorry for putting you off.
Okay, sorry, I think I need to ask comment or Rupenda a question. So when he was deploying, he used user data. So we actually thought of using user data, and the reason we used the script was that we needed to, like, because of the output. So how did you like configure your output? You know, we have like the endpoint and everything that we needed. So we don't have it yet. So we didn't have it until Terraform created. So how did you make that configuration?
See, we can do that. If you see in my presentation, so what I did, I was also creating the endpoint, and I was not manually putting it. Everything, my every file was having it. So there is a way to call the files. There is a way to fetch the data from output. In the AWS, whenever we are going to do, suppose our application is working and suppose in the night it is getting crash. So how our agentic AI will come to know? So there is a Lambda function. So whenever, what it will do, it will fetch whenever the CloudWatch get any error. So there will be some applications, there will be some services. Okay, so we need to configure, we need to write the Lambda function. Suppose I know Python. So I will write a code in Python. It will fetch the CloudWatch log. If anything wrong happen, then it will get that logs, then it will tell the SNS and SQS to send the emails, and this kind of thing is happening. So somehow we can extract the data from any service. So using Terraform, this is the outputs. So you can fetch the output and you can use that output. In my presentation, I was using the RDS endpoint. I never put any place, I never put that endpoint. It is automatically taking. So we are using the variables. Okay. So it is taking. Okay, just share me the entire repo. The entire repo. Don't leave anything. Share with me. I will make it like you will automate. Means as your Terraform apply will be there, you can use this ALB and you can directly access your application. Share the entire repo with me. I will give it to you. Okay. I will tell you.
I'll share.
There is a flow.
I'll share the repo. Thank you
Yeah,
very much.
this entire repo, make a zip file, and you can directly share me on WhatsApp. I will and I will extract it, because see, you are having scripts. The scripts are not usable here. Because you are not using it, so you are just making it complex. So there is no need of this, because you are just copying and pasting in the backend. Okay, so and so many things are there, but it is very good. You presented it. It is very good.
Yeah,
Just
and
share
again,
me.
next time
I will
when you
automate it and I will give it to you.
Yeah, and next time when you run, the endpoint might change, right? Then every time you'll have to keep changing the script. So instead of that,
Correct.
what Bhupender is suggesting, you whatever the endpoint, Terraform gives something called output, so that output you can use it in the next in the script where you want. It's like that, right,
Yeah.
Bhupendra?
Yes. Yes.
Correct. Whatever output we are getting, we can use as input. Because when we are working on the multi-cloud architecture, so whatever output we are getting from AWS, we can use it as input in Azure or GCP. Suppose how the reasons are working. Suppose AWS is getting failed or some reason is not working. So the traffic is migrating to Azure cloud or the GCP. So this way it is working, like services are there. We are invoking the services. They are getting like, okay, this thing is not working. Then ALB is coming in the picture and they are targeting the Azure VMs or GCP VMs. So likewise, we can use the output as input.
Yeah, you are very right, Bhupendra. You are very correct.
And also the order, I think generally RDS gets created, right? And then your your EC2. Because twice I ran it, every time RDS only got created first.
See, the thing is, we are creating RDS because it is taking time. So we are creating it first, then we are creating the EC2 instance. So that time,
Right.
till that time, when our EC2, because EC2 is not getting that much of time as RDS is taking. And again, the RDS, when it is started, so it is having little, means some time it is taking. So that's why we are making some pause there. In my code, there is some pause. So we are waiting for RDS and then our application is working. So likewise, we have to configure.
Okay, so you're waiting first for RDS to complete, and then only you're running. Then like you're pausing at that point, so that till it is ready, and then only you're going for the next EC2.
Yeah, because see, RDS, why we are using, see, there is a connection between RDS and MySQL client. So what we are doing, we are creating database using RDS and we are installing MySQL client. So it is taking some time to communicate, to create the database. And again, it is fetching the queries. Like we are, whatever we are putting, we are seeding that data also, like our books and everything we are seeding in that. So it is taking some time to create that things. So that's why we are pausing, we are giving some pause to it so that everything can happen and we can get the perfect output. So that's why we are giving it time to spin up and do the things correctly, and it will give the proper output. That's why we are giving, if you are not giving that interval to it, then it will fail, and you won't be able to get the output you want. So that's why we are giving it some time to spin up and to come in picture.
Upendra, sir, are you saying it's advisable to create the database first before going to create the app tier because of the communication? So it won't happen the way it happened when you were deploying yours.
Sorry, I'm not getting you.
So are you saying we should create the database first because it takes time to create, so that it will communicate at the right time? You remember when you were testing the endpoint, the IP, it took a little while before it communicated. So are you saying it's
See. It
advisable to
depends.
create?
It depends. No. It is not like that. I am saying like that. We are writing the code in that way. But see, I am running the Terraform code, it is like if you are putting something up and something down. It is not like that. It is when the Terraform code is running, the AWS infrastructure is creating as they have their setup. Like it will create the VPC, then it will create the subnets and all that thing. So it is like it is creating it in its own way. Okay. RDS is, again, it is creating the RDS, because when you will see the logs, when we are running the Terraform code, it is creating the subnet, then it will create the RDS first, then it will create your EC2 instance. I will share the screenshot when I was doing this thing. So it was creating the subnet and all thing, then it was creating the RDS, then it was creating the EC2 instance. So somehow it is having that flow. So it knows, I think it knows that RDS is taking time or configuration is there. So that is why again then it takes time, and we are putting the data in there, so it takes time. So maybe this is the way it is working. So I'm not saying, but it is working in that way. In my case, it is working in that way. In your case also, it will work in that way also.
Okay.
Because
So that's the
when
pattern
you
it
are applying,
follows automatically.
yeah, when you are applying, when you are doing Terraform apply, then you can see that it is creating the VPC, then it is creating the subnet, then it will create the database, then it will create your EC2 instance. Likewise, it will show you the logs.
Yeah, even if your EC2, the code is before your RDS gets created before your EC2. Because there's a dependency, because database is required before you can run your servers, right? You're going to connect to the database and all that. So
Yes.
the order always is
So it is the
internally
AWS flow, not mine.
Yeah. It is taken care by internally. It's taken care that order in which it comes.
Okay. Irrespective of whichever one comes first in the VPC.
See, you are providing the infrastructure. How means the thing? It is like you are saying to AWS, okay, I need this infrastructure, but how it is provisioning, AWS is handling that thing.
Yeah.
Because you
sir.
can't create subnet before VPC. So this is the way they are provisioning the resources.
Yeah, thank you. It's clear. I like that. Thank you, Anuradha. Thank you.
I have a question. Sithi is there? I have a question. When she was explaining the architecture.
Washima is there? I don't think.
She is here, but
maybe it's night, so.
Okay, fine.
Okay, guys, thank you so much. You have done very well job. It's too late now.
Yeah,
So it's very late.
12.
Around.
Yeah. Great.
Okay, no problem
Thank
at
you.
all.
Thank you
We
so
have
much.
done all the
Lovely
things. So
session. It was very lovely session.
Yes.
Thank you,
Evening
everyone.
session. Thank you so much. Guys,
Thank
please
you.
remember, Bhupender and Radha and team, please remember tomorrow is the Thursday. We have a interview session in evening time. So please ask your team to prepare that. Only Terraform topic will be there. We have already shared question answer sheet. Okay.
Okay. So they have to attend the interview, right?
This should attend. I mean, the nomination form I already shared. So they should nominate first. I mean, we are going to attend this interview kind of thing. Then they can attend.
Okay.
Time will be same. Yeah, time will be same. Okay, guys. Thank you so much. Bye.
Thank you.
Thank you,
Bye-bye.
guys. Thank you, everyone.
Yeah, thank you.
Yeah,
Thank you,
thank you,
sir.
everyone.
Good night.